Hello doctor, we are from group 6. Today we are going to introduce our products. Nowadays, pets have become an important part of our families and ensuring that eat properly is crucial for their health. However, busy schedules often make it hard for us to supervise every meal. This is why automatic pet feeder have become so useful because they help us to have our pets get fed on time and even when the owners is away. The market was selling the automatic feeders that mainly dispense food according to a set schedule. But here is the problems. Just because the food is dispensed, but does not mean that the pet has actually eat it. This gap can lead to missed or incomplete meals, which could affect the pet's health and makes the owners unsure that whether their pet is properly fed. The project is to solve this issue with two key ideas. First, meal verifications, where the feeder can detect whether the food is actually eaten. Second, an adaptive feeding response, so that system can be adjusted if a meal is skipped or partially eaten. So in a simple terms, our feeder works as a closed-loop system. The schedule tracks the food dispensing, and the sensor detect consumptions. The system responds adaptively, and the feedback is used to adjust future feeding. This turns a passive feeder into an intelligent, responsive system that ensures pets are properly fed even when the owner was away.
For these sections, I will explain how we identify customer needs, why certain needs are more important, and how these needs are translated into measurable specifications. One of the most frequently reported issues is uncertainty about whether pets actually consume the foods dispensed. In many cases, food remains in the bowl after feedings, yet existing feeders only confirm food released rather than actual consumption. Another major concern is the reliability of feeding records. Most systems generate feeding histories based on scheduled dispensings, not real eating behaviors. As a result, skip or freshly eaten meals may go undetected, particularly when owners are away from home. Although some feeders include cameras, users often mention that continuous monitoring is impractical and does not guarantee feeding certainty. This indicates that visual access alone does not effectively solve the problem. In addition to feeding assurance, users also emphasize hygiene and safety, such as easy to clean component and stable design suitable for daily use. Next, to translate these customer needs into engineering terms, we identify key product metrics. For example, meal detection accuracy measures how reliably the system can confirm that foods has actually been eaten, directly supporting the needs to know whether the pet actually ate. Similarly, feeding records accuracy ensures that feeding history reflects the real consumption rather than scheduled dispensing alone. Together, these metrics enable the system to provide clear and reliable feedback, reducing the needs for continuous manual monitoring. Rather than focusing on adding multiple features, our specifications prioritize accuracy, reliability, and verifications of feeding outcomes.
Most automatically pet feeder only focus on dispensing food. Once the food is released into the bowl, the system will assume that the feeding is successful. However, in the real situation, the pet may not eat the food at all or just eat a part of it. This will cause the inaccurate feeding record and makes the pet owners unsure whether their pet are properly fed. Because of this problem, our product is designed with a different focus. Instead of only dispensing food, it focuses on verifying accurate feeding. The main idea is to confirm whether the pet is really eat the food after it is dispensed. By doing this, missed meal can be detected, food waste can be reduced, and the owner no need to consistently check the feeder. And this design focus improve feeding reliability and increase user confidence, especially during the unattended feeding. Our automatically pet feeder works as a closed loop system. The system receives electrical power, dry pet food, and feeding settings such as feeding time and the portion size. First, the feeder dispenses a controlled amount of food into the bowl. After dispensing, the system does not end the process. Sensor near the bowl monitor the food for a short period of time. Based on the sensor feedback, the system will check whether the food is fully eaten, partly eaten, or not eaten. And this step will allow the feeder to know the actual feeding result. If the food is not fully eaten, the system will take action. It may redispense food or adjust the next feeding based on the preset rules. At the same time, the feeding result is recorded and shown to the user. This system changed the feeder from a simple dispenser into a one that can check and respond to the feeding behavior.
Moving on to concept generation, to address the core issue of dispense versus actual consumption, our team explored 6 distinct design directions. We began with a reference concept based on current smart feeders in the market. From there, we expanded into different priorities. We explored a compact feeder for small living spaces, a dual bowl feeder to support multi-pet households, a smart display feeder that focuses on user interaction, and a modular feeder that allows long-term hardware customization. Through these alternatives, we intentionally tested different balances between functionality, complexity, and user experience before converging on our final direction. To make an objective decision, we applied both concept screening and weighted scoring. The evaluation focused on 5 key pillars, which is meal completion detection, adaptive response, usability, safety, and feasibility. While some concepts performed well in specific areas, concept 5 clearly stood out. It was the only concept that strongly addressed the core behavioral problem without increasing cost or system complexity. More importantly, Concept 5 does not rely on additional screens, modular components, or increased user intervention to improve reliability. Instead, it solved the problem at the system level through behavior verification and adaptive response. It offered the best balance between reliability, simplicity, and real-world feasibility. Now, let's move to the final concept design, which is detailed in section 8 of our report. Concept 5 follows a less is more psychology, allowing the feeder to blend naturally into indoor environments. The key innovation is the integrated sensing band, which discreetly houses the camera and behavioral sensors. This allows the system to verify feeding activity without relying on bulky cameras or constant user monitoring. In addition, the feeder features a stable, tamper-resistant structure, a flush vertical food window for passive monitoring, and an embedded feeding bowl to improve hygiene and reduce spillage. Overall, Concept 5 transformed automatic feeding from a simple dispensing task into a reliable closed-loop feeding system that provides genuine peace of mind for pet owners.